Hello friends, in this video, let us discuss about linear search or sequential search. So assume that I'm going to give you a book which has unordered page numbers and it has 100 pages. Like the first page is marked as number 56, the second page marked as number 89 and so on. That is, the point is, it is randomly numbered. Now, I'm going to ask you to find the page number 50. What will you do? Since the page numbers are unordered, we don't have any choice other than searching it page by page. For example, take the first page. If it is page number 50, we are done. But if it is not, then we have to go to the next page and do the same process until we find the page number 50. And if we run out of page, we can conclude that the page number 50 is not in the book. So this is exactly what is linear search or sequential search. That is, we have a book with unordered page numbers and we have to find a particular page. So we have to check each and every page from the first page to the last page till we find it. So say this array with 5 elements. We have to find the key 50. So we will compare the key with first element. It is not the key. So go on and compare the key with second element. It is also not the same. So go on and compare the key with third element. Again, it is not the same. So check the fourth element. Again, the comparison fails. So compare the key with fifth element. And now it is true. The fifth element is the key. So we have found the key by comparing the key with each element from first to last. Now let us search for another key 20. First element 10 is not the key, second element 30 is not the key, third element 60 is also not the key, fourth is also not, and fifth is also not 20, which is the key. And since we have completed the array, we can say that the key is not present in the array. So that is linear search or sequential search. Now let us see how to implement it in C language. First, let us define the size of array as 5. And we have the main function and a function linear search. So execution begins from the main function. First, let us declare the array page number with elements 86, 91, 34, 50 and 0. And the key as 50. So we want to search the key 50 in the array page number, and we will call the function linear search, which will perform linear search operation. We will pass the array, its size and key to be searched into the function, and the function will return 1 if the key is found. Otherwise it will return 0. So we have if linear search of page number, size, key equal to 1, print search found, else search not found. So the function is called and control gets here, and the array page number is stored in ARR and size in size and key in key. Now we can simply perform linear search using a for loop. We will iterate over the array, and in each iteration we will compare the key and the element. So declare an integer variable I, and we have the for loop for I equal to 0, I less than size, I plus plus. So I will take the values 0, 1, 2, 3 and 4. And in first iteration I equal to 0. So check if ARR of I, that is ARR of 0, equal to key, which is 50. And it is not. So increment I and start the next iteration. Now I equal to 1. So check if ARR of 1 equal to 50. Again this if fails here. So start the next iteration. Now I equal to 2 and check if ARR of 2 equal to 50. Again if failed. So increment I and I equal to 3 now. In next iteration, check if ARR of 3 equal to 50, and it is. That is, the key is found at index 3. So return 1. And here in main function, this return value is 1, so if becomes true. and prints search found. Now let key equal to 30. So let us search for 30 in array page number. So the function is called by passing the array, size and key, and control gets here. We will iterate over the array, and in each iteration we will compare the key and the array element. So declare the integer variable I, and we have the for loop for I equal to 0, I less than size, I plus plus. And in first iteration I equal to 0. So check if ARR of I, that is ARR of 0 equal to key, and it is not. So increment I and start next iteration. Now I equal to 1. So check if ARR of 1 equal to 30. Again if fails here. So start the next iteration. Now I equal to 2 and check if ARR of 2 equal to 30. Again it fails. So increment I. So I equal to 3 now. In next iteration, check if ARR of 3 equal to 30. Again it fails. So increment I and I becomes 4 now. In next iteration, check if ARR of 4 equal to 30. Again it is not. So increment I and I equal to 5 now. And now check the condition I less than size. And 5 is not less than 5, so this condition fails. That is, we have completely traversed the array. So control comes out of the for loop and returns 0 as the key was not found in the array. So here in main function, this returned value is 0, which is not equal to 1. So if fails, and control goes to else part and prints search not found. So that is linear search, and this is how we can implement it. Now let us discuss about the time complexity of this operation. The best case is when the key is present in the first position. Then only one iteration is needed. So the best case time complexity is order of 1. The worst case is when the key is present in the last position. Then we will need n iterations to find it. See, here the key 50 is present in the 5th position. So we will need 5 iterations to find it. That is the size of the array. So the worst case time complexity is order of n.